Beneath our feet, immense forces are constantly at work, reshaping the Earth's crust in ways both dramatic and unseen. While the surface appears calm, hidden tensions are building along invisible lines, preparing to release powerful energy. Understanding where earthquakes originate is not only a journey into the Earth's interior, but a crucial step towards safeguarding our future. Earthquakes originate deep within the lithosphere, the rigid outer layer of the Earth, along breaks in the crust known as faults. These faults are not just cracks, they are dynamic zones of stress and movement. Over time, tectonic forces cause blocks of the crust to shift, locking together and storing energy. When the pressure exceeds the friction holding the rocks in place, it releases suddenly, causing the ground to shake. This rupture typically starts at a single point on the fault, called the focus, and spreads rapidly, generating seismic waves that travel outward to the surface. There are three primary types of faults: normal, reverse, and strike-slip. Each occurs under different stress conditions: tensional, compressional, or shear, and each results in distinct patterns of movement. Normal faults often form where the crust is being pulled apart, reverse faults where it is compressed, and strike-slip faults where blocks slide past each other horizontally. These zones are often mapped by geologists and seismologists to predict regions of potential seismic activity. Fractures, while similar to faults, do not always show significant displacement. They are cracks where rocks have broken due to stress but may not necessarily move. However, in many regions, fractures can develop into faults over time, especially when subjected to ongoing tectonic pressure. Their presence is a clear indicator of geological weakness, points where future movement could occur. Seismic activity is especially common along plate boundaries, where tectonic plates meet and interact. The infamous San Andreas Fault in California and the subduction zones along the Pacific Ring of Fire are prime examples. However, intraplate earthquakes, those occurring far from plate boundaries, also remind us that fault systems can lie dormant for centuries before releasing devastating energy. Understanding these geologic features is not just academic, it has real-world implications. Urban development near fault lines, lack of proper building codes, and inadequate emergency planning can turn a natural event into a human tragedy. Through education and science, we can mitigate these risks and build more resilient communities. Have you ever wondered if the ground you walk on is silently shifting beneath you?